Hi everyone, in this video we are going to discuss the second law of thermodynamics. So we've already talked about the first law, so just to review, our first law of thermo is just saying that energy cannot be created or destroyed. It can only be transferred. Now our second law of thermodynamics actually has to deal with entropy. So we'll talk about what entropy is in just a second, but let's get the definition out first. So the second law is simply that the entropy of the universe. This is super important. People always want to drop this section off, but you can't. It is the entropy of the universe. That's a very specific term. Is always increasing. So our environment, our world is always trying to get to a place of greater entropy. Now, what is entropy? Well, entropy is a very unique thing. We typically represent it with a capital S. Yes, it must be a capital S. The capital letter just represents that it's a state function. You don't need to know that, but you do need to know it's a capital S. Now, what is entropy? It is simply the dispersal of energy at a given temperature. Yes, you need to know that part. It is at a given temperature. We cannot discuss entropy if it's at a variety of temperatures. That puts a whole new conditions onto it and it just gets really complicated really fast. This course, dispersal of energy at a given temperature. Now, that is really hard to visualize, especially if your chemistry background is not very strong. But so let me try to give you an example to illustrate what that means. So picture yourself in a large room where you're really hungry. So it's maybe like 11:30, maybe 11:45. You're getting really close to lunchtime. You're in a horribly boring lecture class, so probably physics or something like that, right? So horribly boring class. Somebody walks in with a giant burrito. So you're in the opposite end of the room. Eventually, you're going to smell the wonderfulness of the queso or the salsa or whatever it is. You're going to be able to smell it. Because what happens is those energy particles, the gaseous particles, come up, they grab the snifty part, the smelling part of the burrito, and it moves throughout the room, moves throughout the lecture hall. The energy is dispersing. In the same way where you walk into a room and you don't suddenly pass out and die, it is because the oxygen has dispersed throughout the entire room. It's not just sitting in the corner of one room. It is moving, it is spreading out. The universe is always trying to spread out its energy as much as possible, and we talk about that in terms of entropy. Now, why are we talking about this? What does this have to do with combustion and power plants? Well, essentially, remember when we said that the power plants are not 100% efficient? The second law of thermodynamics 100% supports that. It is simply saying that it is not possible for a process like that to be 100% efficient because it is always losing energy as a form of heat. So when you go from potential to kinetic energy, boom, you lose some energy as heat. When you go from kinetic to mechanical, you lose some energy as heat. Mechanical to electrical, you lose some energy as heat, which is why our power plants are only 30 to 50% efficient. It has to do with the second law of thermodynamics. Now, I know that seems a little complicated and it's really hard to wrap your mind around entropy, but just keep picturing it. It's the dispersal of energy. These molecules are trying to spread out. They don't want to be glopped together in the corner. Now, let's see if we understand that. A ball is dropped, okay? So we drop a ball. A ball is dropped. Now, here is the question. That let's say it's about 10 feet above ground, okay? After, let's just put 5 minutes, after 5 minutes, some unit of time, the ball finally stops moving. The ball stops moving. Is this an example of the first or second law of thermo or thermodynamics? Thermo is just abbreviation. Go. Did you get an answer? Hopefully you did, and the answer is definitely the second law of thermo. So here's what happens. You have a ball 10 feet above the air, you drop it. Potential energy converted to kinetic energy. The second it hits the ground, it's going to lose some of that energy as heat energy or thermal energy to the ground. Then it goes back up. Kinetic, 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 potential. Back down. Kinetic, 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 hits the ground, loses some of that energy as thermal energy or as heat. This is definitely an example of the second law. All right, one more thing. One more question. Which law or laws of thermo occur in a power plant? Or what do we see evidence of? Okay, go. Did you get an answer? Hopefully you did, and the correct answer is both. We definitely see evidence of both the first and the second law of thermo in a power plant. Okay, first law, energy is not created or destroyed. We see evidence of that as it's being transferred from potential to kinetic to mechanical to electrical energy, constantly transferring energy. But we also see that these processes are not 100% efficient. We are constantly losing energy as heat energy throughout this system as we're going from our coal all the way to electricity. That is an example of the second law of thermo. So we see both of these laws of thermo inside a power plant. Good luck, take care of yourself, drink water.